Hi everyone, welcome to this session on AWS Service Catalog and Terraform Cloud. My name is Arnaud. I'm a technical product manager for AWS, working for AWS for 4 years now. And with me today, we have Taylor from HashiCorp. Taylor.
Hey everyone, I'm Taylor Brooks. I was one of the engineers who built the Terraform reference engine.
All right, so far at AWS, I mainly worked on security and governance feature. And the last feature I had a chance to work on is the feature we're going to talk about today, which is the integration of AWS Service Catalog with Terraform Cloud. But before I start, I just wanted to underline that this feature is the result of a strong collaboration and close collaboration between HashiCorp and AWS. And I really think that you're going to be able to feel it when you're going to test the feature. Super excited by the feature, and I hope that you're going to be as excited as I am after the session. Oh, we don't have the... All right, let's get started. So first, let's talk a little bit about what is Service Catalog and what are the benefits that you're going to be able to get by using it. All right, so as you know, AWS is growing really fast. Today, there are more than 250 services, and 250 services, and it's becoming more and more challenging for cloud administrator and builders, even experienced one, to make sure that they can manage the access to their resources and make sure that everything that is being everyone in their enterprise have access to the right resources. And it's also challenging today to make sure that everyone that is being provisioned in their environment is provisioned the way they want, right? And this is where Service Catalog comes into play. Service Catalog is a tool that allows you to store and manage your infrastructure as code templates that you can then govern and distribute to your builders in your organization for self-service provisioning. And Service Catalog offers several benefits. Number one, we offer the governance tools that you need to make sure that your infrastructure as code template is governed the way you want, right? So in Service Catalog, you're going to find different types of control. You're going to be able to have the mechanisms that will allow you to manage the access to your infrastructure as code and make sure that the right folks in your organization have access to the right resources. We have the controls to make sure that everything that is being deployed is in compliance with your internal rules, right? But at the same time, we want to make the process as fast and as flexible as possible. And we want your builders to be able to experiment quickly and innovate fast. And for that, we have the self-service provisioning feature. And finally, Service Catalog will help you to scale your infrastructure as code templates within your multi-account environment and make sure that you can distribute that to everyone in your company really fast. So overall, Service Catalogs helps you with innovating fast with the right governance controls in place. All right, so now let's talk a little bit more about how Service Catalog works. And for that, I'm going to walk you through the end-to-end customer experience step by step. So in Service Catalog, you have two personas. You have an administrator who is, for example, your cloud platform architect in your CCO team. And you have an end user. So the end user can be like an engineer, a database admin, a data scientist, whatever, right? So the first thing that you have to do as an admin when you arrive in Service Catalog is to upload an infrastructure as code template in your catalog. So you can use a CloudFormation template in JSON or YAML format. And with this new feature, what we have done is that you can now use your CloudFormation, your Terraform configurations, right? And you can repeat that operation like for all the templates that you want to catalog in your in-service catalog, right? And once you have done that, you can group and organize the templates in a portfolio and manage the access, right? At that point, you know that the right people in your organization have access to the right templates. And the last step for the admin is to add some controls, govern the service catalog products and the portfolio. And for that, we offer like different types of controls. So, for example, you can create versions of your templates, and you can control what is configured in each version. You can make sure that everything that is being deployed by the folks in your organization is deployed with least privileges, which is a secure way of deploying resources on AWS and also an AWS best practice, right? You can also, like, for example, like, use controls to categorize your templates and do much more than that. And once you've done that, basically you're good as an admin. You know you have like your catalog of infrastructure as code templates that is governed the way you want. Only the people that you want to access to certain things can do that. And now you can share those portfolios with the end users, right? And like in your multi-account environment at scale. And as an end user, simply what I see is the list of service catalog products and versions that I have access to. And I just can like simply deploy them. All right, so now that we have a better understanding of service catalog, how it works, let's switch to the Terraform Cloud integration. And first, let me like show you why we decided to build that feature. So we know customers use a wide variety of tools and technology to manage their cloud infrastructure. And often it's a mix of AWS services and third-party tools. And when it comes to infrastructure as code, Terraform is really often a key piece of their infrastructure, right? And the problem was that, there was no easy way to integrate those Terraform configuration into AWS. And also, it was challenging for customers to provide self-service of those Terraform configurations. And this is why, with HashiCorp, we decided to fix that and build the feature. All right, now let's look at what is the design of the solution that we are proposing. So first, let's talk about the Terraform Cloud, the Terraform Cloud reference engine. So unlike with CloudFormation, where AWS manages the provisioning engine, for Terraform, you're going to have to own and manage the infrastructure that's going to communicate with your Terraform Cloud. And to help you with that, we have released a Terraform reference engine that will create and install all the code and infrastructure required for your Terraform engine to work properly with Service Catalog. This is like the SQSQ, step function, etc. that you see on the slide. And we're going to go to that a little bit later. All right, this is an open source project that you can find on GitHub. It's a one-time setup. It's all serverless, so it's kind of easy to use. And it only takes a few minutes for you to go through the process and have your Terraform Cloud engine up and running, right? On the Service Catalog side, this feature introduces a new product type. That is the Terraform Cloud product type. And really, you can think of this type as a mechanism that establishes a connection between Service Catalog and your engine, right? Technically speaking, the type contains a reference to an SQS queue that exists in the engine account, and that Service Catalog is going to use to send the provisioning payload from Service Catalog to your engine, right? So again, number one, you set up the Terraform Cloud engine. It's easy, it's fast. And then if you want to provision a Terraform Cloud product, a Terraform configuration, what's going to happen is that Service Catalog is going to send the provisioning payload to the SQS queue that we've just talked about. And then the Terraform Cloud engine is going to provision the resources that are contained in the Terraform configuration. All right. Now, really quick recap on the key benefits of the feature and the capabilities that you're going to get with this feature. So, access management control with portfolio. Least privilege resources deployment with launch constraints, versioning of your Terraform configuration, sharing and distribution of that infrastructure as code templates within your organization with hundreds of accounts and hundreds and thousands of users, categorization with tag. And at the end of the day, like the primary value of Service Catalog is to offer self-service provisioning to the builders in your organization. All right. Before we jump into the demo, let me dive a little bit deeper and show you how provisioning operations work step by step, right? So as you can see here, you have your engine account with all the infrastructure that is required to work properly with Service Catalog. Everything comes from the installation of the reference engine. So you have the SQS queue, you have a queue reader lambda, you have a step function, the Terraform Cloud engine, obviously. So that is in a central account, a hub account, right? And you have a provisioning account where you have an end user, a builder, that's going to deploy a simple Terraform configuration. And to make it simple and illustrate that, we are just going to show like the deployment of an EC2 instance. OK? So let's get started. So the user starts the provisioning operation of the EC2 instance. Then Service Catalog sends the provisioning payload to the SQS queue. Then you have a queue reader lambda that reads the queue and starts the engine workflow. The engine workflow uses Secret Manager to authenticate with Terraform Cloud. All right. Then the workflow creates a project, a workspace that is set up to assume the role in the provisioning account. Then the Terraform Cloud assumes the role and creates the EC2 instance, right? So at that point, the EC2 instance is created in the user account. But now we need to surface back, like the status of the operation, all different things in Service Catalog. So the engine workflow sends the provisioning results back to Service Catalog. Service Catalog assumes the role, create a resource group, which is the mechanism that we use to group the resources that are in the Terraform configuration. So in our case, it's just an EC2 instance that's going to be in the resource group. But if you have like more complex Terraform configuration, all the resources related to your configuration are going to be there. Service Catalog tags the Service Catalog product and tags the EC2 itself, the EC2 instance itself, right? And this is it. This is how it works. And this is what Taylor is going to show you in more details during the demo. And Taylor, handing it over to you.
Awesome. Thanks. All right, how's it going, y'all? Before we jump into a demo and a deep dive, I just want to quickly kind of just set the stage, I guess, for what we've done kind of leading up to this demo. What we've got here, kind of just starting off, is 2 AWS accounts. We have a hub AWS account, and this is the account where the Terraform Cloud reference engine has been provisioned. It also has in it a portfolio that's going to have one single product. That one product is just an S3 bucket, nothing too crazy. We also have a Spoke AWS account, and the Spoke AWS account is basically like, it's where the work actually gets done. It has the product shared with it, and a launch role, which matches the launch role on the portfolio inside of the hub account. And then finally, it has an IAM identity provider. And this is going to be what Terraform Cloud uses to authenticate with AWS and actually provision the resources for us. And then finally, we have our end user, who just really needs an S3 bucket, as you can see. So just to recap, 2 AWS accounts. We have the engine in the hub account, and then a single product, just an S3 bucket, and a user who really needs a bucket, basically. Okay, and one last bit of a prequel here. When I said like this product is super simple, I really meant it. Here's the Terraform configuration for that product that you see here, right? As you can see right at the top, we have our AWS S3 bucket. It's got a name, and that bucket name, as you can see, has a little bit of interpolation going on in it. It's also going to have a random string in it, just to, hopefully that bucket name will be globally unique. And then that string is controlled, or the length of that string, rather, is controlled by a variable. And the variable has a nice description, has a default. That will come into play later, foreshadowing, and then an output. So we're going to see how AWS Service Catalog handles this variable and output. Should be good. OK, so with that, we're going to jump right in. So we're going to be jumping in from the perspective of a user. So here's the AWS dashboard for Service Catalog right here. You can see we're logged in as our user. Up in the right, I need a bucket, fitting username. And finally, just one single product, right? Best bucket. And indeed, it is the best. So the user they want a bucket, so they'll click that. And then they'll click Launch the product. So go ahead and launch it. And then they're presented with a list of options, right? So you have the product name here. We're just going to give it a basic name like our best bucket, right? Name whatever they want, right? Product versions, this is the revisions. So you can create different revisions for your products as they change. We'll just go ahead and select this latest revision. Oh, you can see also the revisions have a description on here. Hopefully your GitHub commit messages are better. And we'll go ahead and click this one and move on. OK, cool. And parameters. So here's that variable in that Terraform configuration here, the random string length. You can even see the description was parsed in here, too. So we'll just give this a little tweak. The default value made it in. We'll tweak it, make it 15. And tags. This goes back to what Arnaud was talking about. The tags are here, and these are the tags that were set by the person who created the product. So these are kind of enforced. We can just go ahead and create our own custom tags, too. The user can set their own tags. So these will be billing tags as well that are attached to all of the stuff that we provision. OK, cool. So the engine's working right now already. It'll be creating a project, a workspace, all inside Terraform Cloud. So if we jump to Terraform Cloud, kind of going behind the scenes, here we are. You can see workspace going, runs going. We're provisioning something already, right off the bat. If we click into this thing, run queued in planning. We also can see on the variables section here on the left, you can see variables that were set for dynamic credentials. So these are the things that will enable this, Terraform Cloud to actually authenticate with AWS. OK, cool. And another nice thing about this is we use step functions to orchestrate all this stuff in the background. So we can look at the step functions execution inside the hub account and get a really nice DAG graph of like what it all looked like and what happened. And here it is now. So this is inside the step functions dashboard in our hub account for AWS. And you can see there's this send apply execution that's right basically at the top here. This is where most of the magic happened. This is when the engine reached out to Terraform Cloud, created the workspace, created the project, did all that magic, queued the run, and then a polling process. So the engine will just poll Terraform Cloud, hey, is the product good? Any errors? If there are no errors, which hopefully there never is, we get notified of a run result. It'll notify Service Catalog, hey, product was provisioned, everything went great. If there were errors, those errors will get reported and they'll actually get shown to the user. But in this case, everything went green. It's beautiful. Service Catalog is now should be notified that this product was provisioned successfully. And if we jump back to the user's perspective, first try, wow, successfully launched our best bucket. It's here. If we scroll down to the bottom, you can see resources, right? This is another thing we talked about earlier. You get links to all of the resources that you provisioned. Here's our S3 bucket right there. And all in these tabs to the top here, if you go to outputs, you can also see the output that we had in our Terraform configuration is also here. So Terraform variables, Terraform outputs, all handled. And yeah, so that's basically what the user would see, really. It's like 2 clicks and a few text boxes, and they have their S3 bucket, and of course, much more complex Terraform configurations would also, of course, be possible. OK, with the time we have left, just going over a few other things to know. Just kind of some bonus tidbits for you all here. We have launch role constraints. So when you create the product launch role, a few things to note. It's going to need access to the Terraform configuration files inside the hub account. When you actually created the product, you created you put the configuration in a tar file, put it in S3, and the launch role needs to be able to actually read read those Terraform configuration files from S3. So it needs permission to do that. It also needs, of course, the permissions necessary to actually provision your product. So you give an EC2 instance, it's going to need EC2 access. And then also, it's going to need to be assumed by 3 distinct entities. The first being Service Catalog itself is going to need to assume this thing. And then also the lambdas. 2 of the lambdas inside the engine need to assume this role as well. And then finally, the IAM identity provider. This is what actually enables dynamic credentials for the runs. OK, so also automated token rotation out of the box. So the engine uses an API token to authenticate to Terraform Cloud. This token is automatically rotated thanks to this process. So when you actually use the engine Terraform to provision the engine inside your hub account, Terraform will set up this engine and provision an event bridge rule. So this event bridge rule invokes a token rotation state machine that'll also be in your hub account. Basically, it'll do this every 30 days, and that's the default. You can customize that duration to be whatever you'd like. Once this token rotation state machine is invoked, what will happen is the state machine will temporarily pause all of the SQ messages. So anyone who's provisioning new products, those won't actually make it to the engine yet. They'll be in a waiting queue, right? And then any existing ones, we'll wait for those to finish processing. And so once they've finally finished processing and the queue, there's no active products being provisioned, then the token rotator will reach out to Terraform Cloud, exchange your tokens, do a nice little trade, store the new token in Secrets Manager, and then, then assuming no errors, traffic goes back to normal, your engine's good to go, all fine and dandy. In the unlikely event that something does go wrong, I feel like a bit of an airplane attendant when I say that, but resetting the token manually can be done by just deleting the token from your Terraform engine, Terraform, and just reapplying said Terraform. And we even have those commands in the README if you'll ever need them. Hopefully you won't. It's also worth mentioning that, token rotation process, the way it pauses the SQs, this kind of mechanism can be used for whatever reason you want, like, for example, updating the engine if you ever need to. So it comes in handy to just be able to pause traffic. OK. And so that's about it. We have just these 3 bonus links for you all. So the first link there, Terraform Cloud, the reference engine. So that'll go straight to our GitHub repository where you can provision it for yourself. The Service Catalog blog, and then the Terraform, and then the AWS Service Catalog Getting Started guide. By all means, please check out the engine, provision it for yourself. It really does only take a few minutes. Try it out, see if this fits your problem case. And with that, Arnaud, any other stuff you'd like to
thank you so much for your time today. If you have more questions or anything, we're going to be in the hallway for a couple of minutes. So don't hesitate, come to us, and we can answer your questions. And thank you so much for your attention today.